In this video, I will go over the addString function that we are using to test TrieNode insertions. In this particular function, we are calling a TrieNode pointer by reference. We are also calling by reference a const standard string, and we have an unsigned int value. The value corresponds to the location in the string of the character we are currently evaluating. So initially what we say is if we have not reached the end of the word, then we need to keep adding in characters. This particular node has a bool indicating whether or not it's true or false, and then a dynamic array of TrieNode children. What's going to happen is in the default constructor that you created initially, it has a length of 0, and we set it equal to false. Here we check to see if it hasn't been entered yet. If it hasn't been entered yet, what we're going to do is we are going to create a new TrieNode. The new TrieNode is going to be set to true, and in the default, the overloaded constructor, we set it to have an array of 128. Now each time it creates 128 of these TrieNodes, it's going to call the default constructor, each of which will have a length of 0. I'm going to show you in a moment why this is important. So to do this, we create the temp node, and then the particular pointer, this next level, is pointing to where we would like this particular decision, which correlates to the character. So for example, if this is the letter C, we would get the letter C, cast it to an unsigned integer, and this would correspond to the location in the array within the trie. If it already is there, then we just go to the next step, so that way we don't add in a duplicate. At the end of this function, we see that if the value is equal to the word size, then we have entered the entire word. What we will do next is at this particular location, we will set the unsigned int for a star equal to true to indicate that this is a valid end of the word. What I'm going to do now is once that's complete, I'm going to run make TrieNode test, and we're going to see that it's going to compile and print out everything. We have CAN, just like before, CAN star, then we have DY, and so on. So we see that we have a valid pre-order traversal printed out here. So the question is, why is it important that in the constructor, that in the base constructor I have 0 and false, but in the overloaded constructor, I set it equal to true and then set it to num ASCII. Num ASCII is a static constant equal to 128, which is the total number of ASCII values. So why do we do this? Well, here's what would happen if I set this equal to num ASCII. I would create the root would have 128, and then it would call the default constructor for every single one of the 128 elements in the array. If I set this equal to 128, this one would create 128, and then each one of these would try to create 128, and what would happen is we would eventually get a segmentation fault. And the reason why is because it would use up all the available memory on the data heap. So let me show you this to prove that it will not compile. I'm going to change this to num ASCII and then save and update. Now if I run make clean and clear, and then I run make TrieNode test, what you're going to see is it's just going to hang up for a while, and then it's going to segfault. And we see there it is hanging up. And eventually, if we give it enough time, it will say that it's run out of memory and it will say segmentation fault. In order to fix this, and we see there it is, there's the segmentation fault. In order to fix this, we set this equal to 0. By setting this equal to 0, we only create children in the trie if and only if we're in a scenario in which we need to have a child there. So we see that we use only the memory we need in the try. So what happens is, when I create 128, that's when I'm using the overloaded constructor. That's what I call, in this line of code here at line 23, I call the overloaded constructor. But when it calls the overloaded constructor in TrieNode, and it creates an entire array, each one of these is going to call the default constructor, which means we'll create 128, and it's going to create all of them, but each of these is empty. So therefore, we do not overload the data heap. This is why we also create the temporary node. So that way I can only create children when I absolutely need them. This ensures that I have effective memory use, and we are able to only implement what we need to contain all the characters in the dictionary.